So I want to talk about velocity time graphs, or VT graphs. These are the second types of graphs that we're going to be looking at. Whenever you see a graph that has to do with motion, I want you to first make sure you know if it's a velocity time or a position time. All right, here's the first thing I want you to notice on these pictures. For these top ones, those ones have a positive velocity. If you think of like an XY axis, this one is just the first quadrant. It's like I had this right here. Then the bottom ones, these ones here, it's like I have like, this is my axis right there. Those ones are going to have a negative velocity. So I just want to make sure you understand what's going on with the graph. These are above the x-axis, the top ones, and the bottom ones are below the x-axis. So just make sure that you are aware of what's going on with the graphs here. So I have a few little rules for velocity time graphs. So the first thing is, if you have a horizontal line on a velocity time graph, it means that your velocity is constant. So remember on a position time graph how a horizontal line meant you weren't moving? In this case, most likely you are moving. The only time you're not is if the velocity is down at v equals 0. In this case, a horizontal line here is just going to be a constant velocity. So then the other things are, if we have a positive slope, that means that you are speeding up or you have a positive acceleration. So positive acceleration, sorry if that got messy there, it just means that you are speeding up. If you have a negative slope, that means that you have a negative acceleration. In other words, you are slowing down. So if you have something above the x-axis, I already mentioned that's a positive velocity. Now, that doesn't necessarily mean that you're going faster. It just means that you are going forward. So the positive velocity is going to tell us the direction. If you're below the x-axis, it's a negative velocity. And again, that doesn't mean that you are slowing down necessarily. It just means that you are going in the reverse direction. So be really careful about that. A lot of people get really confused about the difference between velocity time and position time. Just make sure that you know the differences between them. So one little rule is that we're going to use this a little bit. Also, by the way, this is used in calculus. So if you are in calculus now or you take calculus next year, this type of thing will probably come up. So if you have an object, I'm going to put in parentheses from a VT graph, to find the displacement, and by displacement, I mean the change in distance. So to find the displacement of this object, you are going to find the area under the graph. That's the first thing. The second thing is to find the acceleration of the object from a VT graph. You are going to find the slope of the line. All the ones I'm going to give you actually for velocity time graphs are going to be straight lines. We're going to assume that we have constant acceleration, meaning that the lines are straight. In real life, that doesn't always happen, but for this class, we'll make that assumption. So we have two examples for this. I'd actually like to do example 1 together in class. You're welcome to try it on your own. I'm probably going to give you like 5 minutes during class to try it, and then we'll talk about it. So for this example right here, the first question is, what is the acceleration as shown on the graph, and how far did the object travel in 5 seconds? So the acceleration, remember, is going to be the slope of the velocity timeline. So please pause the video. I want you to find the acceleration, including the units. So the first thing I did was find 2 points on my line. This is actually a straight line, so you can use any 2 points, but 0, 0 is probably the easiest one to deal with. And then any of the other points are fine. So I have a point at 0, 0 and a point at 550. In this case, my x value is my time, it's in seconds. My y value is my velocity, it is in meters per second. So that's going to help you out. My x, or time, is in seconds, and my velocity is in meters per second. That's going to help you out for your units. So to find the slope of this line, remember, you do change in y over change in x. So I'm going to do y2, which is 50, and that's in meters per second, minus y1, which is 0 meters per second, over x2, which is 5 seconds, minus x1, which is 0 seconds. So you should get 50 meters per second over 5 seconds, which gives us 10 meters per second over seconds. So I want you to be really, really careful here. You can write it over 1 second if you want. A lot of people see the seconds in the numerator, seconds in the denominator, and they cancel it out, which would give you 10 meters. Keep in mind that acceleration is not measured in meters. Actually, if you notice that in the numerator, the s is on the bottom of that little fraction there, that means that there's going to actually be 2 seconds in our denominator here. So it'll end up being meters per second squared, which hopefully you remember is actually the measure of acceleration. Okay, so the last thing I asked you to do was find out how far did the object travel in 5 seconds. That is asking for displacement. So displacement is going to be the area underneath that line. And if you look at the line there, that line is it's a perfect line, but if we want to find the area, it's like finding the area of this triangle right here. So we're going to actually use some stuff that you guys hopefully remember from geometry, maybe even sooner than geometry. If you're in geometry right now, I'm hoping that you've seen this before. So we have that little triangle. To find the area of that triangle, you're going to use 1/2 base times height. So that's going to be my distance or displacement. I'm going to do 1/2 times my base times my height. So my base is going to be 5, because from 0 to 5 seconds, that's going to be 5. And I'm actually going to keep that in seconds. I keep my unit there. That's my base. So I do, I'm going to write this on the side just for those of you that don't remember that. So area is 1/2 base times height. So my base is 5 seconds. My height is going to be, if I start at 5, go up here, going from 0 to 50, my height is going to be 50. And again, that is in meters per second. Make sure you include the units. So we'll write this out. I have 1/2 times 5 seconds times 50 meters per second. You'll notice that seconds and seconds are going to cancel out because one of them is on the bottom of the fraction. If I multiply this whole thing out, I get 125 meters is left over, which is good because I wanted a distance how far, and so I did get the right units in the end. So that is my answer for that one.